Hi, my name is Matt, and in this series I'll be building an all NVMe NAS. This video is not sponsored. All of this hardware was purchased by myself. Let's get into it. In this video, we'll be looking at two different motherboards from minisforum. I bought the AMD motherboard initially because, Team Red. But when I saw this Intel motherboard had two NVMe slots on the back, I couldn't help myself. I knew that if I used the Synology NIC, which has two more NVMe slots on it, I could have a 10 gig NIC and a 6-drive RAID Z2. In this first video, we're going to look at performance and power usage. For my testing, I've installed Rocky Linux 9 on an external USB hard drive. In my initial testing, I found that this Synology NIC can consume up to 10 watts. So in order to avoid introducing any error, I'm going to be running only two NVMe drives in each of these motherboards. That way it's a fair fight. For the power supply, I'll be using a 500 watt HD Plex, which I've installed in the top of this case. The reason why I chose this power supply is because it was the same price as the SSF power supplies I normally use, and I wanted to try something different. I can't say whether or not I recommend it. This is only my initial experience with it. I'm sure we'll find a use for both of these, but I want to know which motherboard is going to be best for this NAS configuration. So in this video, we'll be looking at both power usage and performance under various tasks which my home NAS might be doing. Both of these motherboards have 2.5 gigabit NICs and are pretty much identical except for the processor and the additional NVMe slots on the AR900i. For this video, we'll be running some workloads that I run in my home lab, an AV1 encode, a large language model inference entirely on the CPU, and of course Geekbench, so we can compare performance numbers. If there are any other tests you'd like me to run in a future video, please leave your suggestion in the comments. So here's my setup. I've got the motherboard installed into a DAN A4 H2O case here on the table, and I've got a real-time readout of the system power usage at the wall. This device allows me to capture the minimum power draw, maximum power draw, and total power draw. Between each test, I'm resetting the device to get an accurate figure for total power use during the run. The screen is being recorded via an HDMI to USB capture card, which allows me to record the output via OBS. This should prevent any performance anomalies that would come from screen recording, as that's being handled by my laptop. Before running these tests, I set the performance governor to max performance for both systems. Starting off with our AV1 encode test, the AMD board takes the win, consuming half the power and finishing in 15 seconds less. Next up, we're running Mixtral, a fairly large language model that's somewhat difficult to run and gives fairly good results. This model has a very permissive license, and there are some good fine-tunes for it as well. In this test, both motherboards perform similarly, about 4 tokens per second, and similar power draw. Geekbench ends up showing that these processors are very similar. The performance is almost identical between the two of these. Either of these motherboards gives very good performance. So which motherboard should you buy? That's going to be up to you. Both these systems use less than 20 watts at idle. The Intel board uses a couple watts less, but both of these are very power efficient systems. The performance is very similar. Under load, it seems like the AMD motherboard is going to be a little bit more efficient. But if you're expecting to use this as a NAS, as I am, the Intel board is actually the winner due to those 4 NVMe slots. Now, there are some issues with those NVMe slots. They're managed by a chip which doesn't seem to support NVMe to SATA. So if you were planning on putting in a bunch of SATA drives, maybe you have 3 NVMe or 2 NVMe and 5 SATA, well, that's not going to work with the Intel board. There is a workaround I found where you use a PCI Express card, but obviously this isn't something I'd recommend doing. That said, I plan on diving into this a little bit deeper in a follow-up video. A few more things I want to mention is that while these systems are only listed as supporting 64 gigs of RAM, I actually had no problem getting them to recognize 96. With some RAM kits, I was even able to get higher speeds, up to 5600. The Intel motherboard has controls where you can adjust the RAM speed, but the AMD motherboard does not. So, if the AMD motherboard detects your RAM successfully, great, you can get 5600. If not, it's going to be whatever speed is detected. The Intel on the motherboard, though, on the other hand, you can just adjust. I have 16 gigs of SK Hynix RAM, and that detects fine at 5600, but my 96 gig kit from Crucial does not detect at 5600. It just falls back to 5200, which I'm okay with. Hopefully you found some of this information helpful. Make sure to subscribe so you can follow along with my next video where I'll show you the completed NAS. I promise it won't be yet another video about TrueNAS or Unraid. I wanted to get a bit creative with the boot drive for this, and I decided to actually put my boot partition on the ZFS pool. So I'll be using Alpine Linux running on ZFS. So hopefully that'll be fairly interesting.